Dear students, now we are going to construct hypocycloid. The hypocycloid, let us construct one reference line and then construct one vertical line. Here we can take 120 degrees because in the previous video I have just given some diameter of a rolling circle as well as the generating circle. The same diameter we can take. So here 160 degrees this side and 60 degrees this side we can take. This is 120 degrees included angle to exactly match the circumference of the generating circle will be equal to the arc length of the rolling circle. Now let us consider 90 mm as the radius of the rolling circle. So from here I am just constructing one line or one arc which represents your rolling circle. Now the generating circle has got the radius of 30 mm. So I can take 30 mm diameter as a radius, and then from here the circle is going to revolve inside your circle. So this is going to be your center of the circle. From this center I am going to construct one circle of 30 mm radius. It is going to revolve in this side. Now let us have the another axis for this circle by drawing a perpendicular line to this. This is perpendicular line, and then the circle I am going to divide into 8 equal parts. That means here I can just bisect this angle as well as this angle, so that we can have, we take this radius, and then from here I am drawing one arc, and then from here I am drawing one more arc to cut each other. Similarly here I am just drawing these arcs. Now this one is divided into 8 equal parts. While naming, you can just do it in this way. If you say it's P, say it's 1, 2, 3, 4, 5, 6, 7, and this is 8. Now this sector, the rolling circle sector, also can be divided into 8 equal parts, since we have divided the circle into 8 equal parts. So at 15 degrees we can mark 1. Now we can divide this, or you can join these lines, or you can divide this circle into 12 equal parts and draw some long lines. This is hypocycloid. Now as usual, the points on the generating circle, we can draw arc through these points. It is 1 and 7. You can just draw one arc. 6 and 2. We can draw another arc. And then 5 and 3. then 4. We can transfer the center also by a separate arc on which only we are going to mark the radius of the centers. So this is the center C1, this is C2, this is C3, sorry, here it is C1, C2, C3, C4, C5, C6, C7 and C8. We have to mark the centers from the arc drawn through C. Now we can take the radius C to P as the radius, C to P as the radius. From C1, you just draw the arc cutting here. From C2, arc the cutting here, C3, from C4, it is this point only. From C5, C6, C7, so these are all the points. This is P1, P2, P3, P4 is this, P5 is this, P6, this is P7, P8 is here. Now we have to draw the curve like this. Similarly, from here we can draw the curve connecting these points. Now this has to be connected like this. This curve is called hypocycloid. Tangent normal is also the same way as, suppose if you want to draw a tangent normal through this point P on the curve, it is between P2 and P3. Between C2 and C3 we have to get that arc. So from this point you can cut the center between C2 and C3, and this has to be drawn to the generating circle radius. This point and this point we have to join and extend it to show the normal. The tangent will be perpendicular to this. This is tangent to this.